Okay, so hello everyone, a very good afternoon to all. And dear authors and invited guests, welcome to the technical session 4A. My name is Anisha Mishra and I am the moderator of today's session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 7th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2023 through Zoom. I hope you will enjoy the knowledgeable and interactive sessions through the day. And in this session, we have 8 presentations and each presenter will be given 8 minutes for the presentation and 2 minutes for question and answers. And on 7 minutes, I will raise a gentle reminder. There is also another request to all the participants that you all please stay connected with us till the closing of the session. And if you have any update or query, then you can write it to me in the chat box. So just before we get started, I would like to introduce you all to the chair of the session, Professor Geeta Navle. Dr. Geeta Navle is currently working as a professor and head of Department of Computer Engineering in Singh Institute of Technology and Science, Pune, Maharashtra. She has teaching experience of 24 years and has 30 plus international journal publications. She has also been a part of 20 plus international and national conferences and has 3 patents. Ma'am, welcome to the session.
Yeah, thank you, Anisha. Thank you so much.
And now we will start with the papers. Yes, and now I would like to invite our first presenter, Rania Alotebi, to present her paper on the title, A Clustering-Based Approach to Feature Selection for Breast Cancer Classification. So, dear presenter, you may please start your presentation now.
Assalamu alaikum.
Yes.
Hi everyone. Do you hear me?
Yes, you are audible.
Okay. Do you see my screen?
Yes, it is visible.
Okay. Bismillah ar-Rahman ar-Rahim. First, my name is Rani Ratebi, master student of data science at Princess Noor University. Today, inshallah, we'll present our paper, a clustering-based approach to feature selection, application to breast cancer classification.
Hello.
We'll go.
Hello.
Yes.
Yeah, your screen is visible, but still PPT is not open.
I didn't.
Anisha, can you see her PPTs?
No, ma'am. It's just the explore area. You have to open your PPT and then share the screen.
Okay. Now it is PPT clear?
Yes, now
Yes.
it's visible.
Okay. Okay, today inshallah we'll present our paper, a clustering-based approaches to feature selection, application to breast cancer classification. We'll go through agenda, introduction, proposed framework, experimental result, and conclusion. Our work in area of machine learning and optimization approach. In this work, we interest with course of dimensionality problem that impacted on the performance of machine learning models, led to some problem, for example, overfitting computational complexity of the model. We can address this by dimensionality reduction through that feature extraction or feature selection. In our work, we interest with the feature selection approach. There is a 3 main approach: filter, wrapper, and the embedded approach. We'll focus on a wrapper approach. The wrapper approach are used with the classifier to evaluate a specific subset of the feature. Also, there is other alternatives. It is called meta-heuristic algorithm based on wrapper approach. It is selecting that most suitable feature subset of the feature without sacrificing the predictive performance. The major shortcoming in the existing approach that using a classification model for objective function. It is highly level of time complexity caused by exploring a large search space as a result of the large number of fitnesses function evaluated. So in our work, we addresses this issue by using the data clustering evaluation instead of classification evaluation as alternative of objective function. Paper objective design, build, and test a framework for feature selection using clustering to perform classification tasks using labeled and highly dimensional datasets. We contributed to develop a new feature selection approach, investigated a potential clustering algorithm to perform that feature selection. We investigated to use that meta-heuristic approach to solving this kind of a problem. Finally, we compare that outcome with the state of the art. Proposed framework. We use the genetic algorithm to select the best subset of the feature using the clustering method. Validation, as we can be outlined in the three stages. In first stage is data preparation. We use that label data, and the second stage is genetic algorithm optimizer as a feature selection, initialize the population, then fitnesses evaluation using the k-means, then selection, then will be a crossover and mutation. The outcome of this stages will be that data set with the best subset of the feature, then will be entered in a classification model to a classification purpose. We'll go in detail inshallah on the next slide. First stage data preparation, we use that breast cancer data set for validation. We clean and prepare this data set, and then we'll go to this data set. When they clean it, go to the next stage, genetic algorithm optimization. First step, initialize the population, generating randomly set of a chromosome for a population. A chromosome is corresponding to potential solution to the problem. As we can see here, the 0 that means that feature not selected, 1 that means the feature selected. This is a population set of a chromosome. Second sub fitnesses evaluation. Each chromosome is evaluated using the fitnesses function. Our fitnesses function outline first will be take that subset according to selected feature, then we'll apply clustering algorithm. Clustering algorithm k-means. The third step that evaluated the k-means results using the F-measure. The F-measure, one of external clustering validation techniques that use it when that our data is labeled. Then return the F-score. This F-score formula. Third, the step 3, roll a tool that uses as a selection method to select that the fittest chromosome. Crossover and delimitation. First crossover, in our study, we use that single point of a crossover. As we can see here, that we take that tail of the chromosome and swapping with the other chromosome. A mutation operator will mutate that our chromosome by swap randomly one or more than bits, as we can see in the same chromosome. Step 5 is stubborn iteration, maximum number of iteration. Final subset of selection. This chromosome offer all iteration specify optimal subset of the feature for given the data set. The third stage, classification method. Following that preceded steps, the data set with the best subset of the feature will be fed to a classifier to make a classification or for a classification purpose. Now we'll present the experimental result. The k-mean result, we obtained that 0.90 F-score, which is good result. Also here we plot that the k-means cluster. As we can see, it is almost the same in the actual cluster, which is indicated k-means is suitable with our data sets. Binary genetic algorithm as a feature selection result. We recording that F-score according to multiple iteration. As we can see here, there is a rapid convergence to provide highly quality solution. We obtain more than 0.19 score. It is very promising and indicated an appropriate selected clustering algorithm as well. Also, we can see in some cases have that small or low score that's indicated the perimeter of convergence. So we can improve the optimizer performance by improving the search capability to find best solution with high score. The classification models result, as we can see in the below table, proposed method is compared with and sometimes auto prefer other method across all the matrix and even the classifier. In final stage, we achieve that best performance result. It is 0.99 by using the proposed method with the SVM classifier. Runtime results, we recording that runtime in several iteration in both proposed methods and other methods. As we can see, our approach is took less time to achieve a good result than a genetic algorithm as a Reaper techniques. So we can conclude that our work is showing that promising results in reducing that computational cost, achieving similar or even better classification performance. Future work, we motivate to extend our work in many directions by considering other meta-heuristic algorithms, also considering other data sets while considering a suitable clustering algorithm that fit their structure. Thank you for listening. If you have any question.
Yeah. Nice presentation, Rania.
Thank you so much.
Yeah. I would like to know what changes you have done in your algorithm so that you got good results than other algorithm.
Yeah, the change in the algorithm. And the algorithm that use genetic algorithm as a feature selection use inside the classification. For example, SVM or what type of the classification model. The change we made it in objective function rather than the classification use the clustering techniques.
No. What you did something new or changes so that you got the good result.
Yes, this one when using that clustering techniques that give us the better feature, and when use this feature in classification model that bring the good result.
Okay. And which data set you have used?
Breast cancer from UCI
From which?
repository.
From?
UCI
Okay,
repository.
UCI data set. And on how many data sets you have tested?
Just it is a primary idea. It's just done one data set. Inshallah, in the future work, we will be extend to use other data sets.
Okay. Thank you so much.
Thank you so much.
Yeah.
Thank you.
Yeah.
Thank you so much for the presentation. And now moving further to our next presenter. And I would like to invite Preeti R to present her paper on the title, A Secure Protocol for Authentication and Data Storage for Healthcare Systems. So, dear presenter, you may please start your presentation now.
Yeah, very good afternoon.
Good afternoon.
Is my PPT visible?
Yes, it's visible.
Yeah. So the paper's title is Secure Protocol for Authentication and Data Storage for Healthcare System. So this paper majorly focuses on the healthcare sector, where the patient doctors can communicate and store data in a secure manner. In my paper, we have proposed in the following phases, like where it has setup phase, a registration phase, authentication, and data storage and retrieval. So the setup phase is basically the phase where the key generator generates a key that is used for encryption and decryption between the data that is being transferred between the patient, doctors, and the hospitals. So the setup phase is basically the key generator phase. The registration phase again has like the patient registration, doctor registration, and hospital registration. The patient registration phase, we have included the timestamp, and we are incorporating the ID-based encryption here. So the registration is made in a secure and an authenticated way. So the initially, when a patient is about to register himself or her, he or she is encrypting the timestamp with the secret key that is generated, and also the ID, the identity of him with the secret ID that is generated, and the encrypted ID is again encrypted using the ID based encryption, and he chooses a password. Then the entire encrypted ID is again concatenated with the random number that is generated, like the random nouns. So when these data are sent to the server not just stores it as such. Instead, the server cross-checks the data with the hospital, whether the patient is actually a registered or a valid user, and then it replies back like, yes, the patient is coming from our hospital. You can store their data. Then again, the decryption process happens in the server and the patient is being registered. So for the protocol which we wrote, we made a security analysis for that, and we were able to see that most of the attacks were like not possible in our case. So this is the screenshot of that. In the doctor registration phase, in the doctor and the hospital registration phase, what we have done is similarly what we did for the patient. We are using the ID-based encryption and also the timestamp. And also here what we are doing is we are getting the digital certificate, that is the registered certification ID from the doctor or the hospital, and we are sending it to the server during the registration process. And the certificate is verified with the nearby medical server. So it will confirm whether the doctor or the hospital is like a registered and genuine one. Only then the doctor or the hospital is being registered to the server. So this is how the doctor registration phase and the hospital registration phase works. And we made the security analysis for both, and also we were able to see there are like more no attacks possible. In the login and the authentication phase, previously during the registration phase, the patient would have registered with the ID. He or she would have encrypted using the secret key, and then only would have sent the data. So here again, he uses the same encryption, but the timestamp and the ID base is like used here. With the ID-based encryption, since he's encrypting the ID, previously he'll be sending the same ID, which is already stored in the server. So when he's trying to log in, he is able to, the server is able to retrieve the data of the patient. And also, instead of just using a password, we are using an OTP authentication here. So it is again like a second verification so that it is from the registered and the genuine patient. This is how the login and the authentication phase works for the patient. And the security analysis we did for the protocol, which for the login and authentication phase, again, we were able to see like mostly no attacks were like possible on that. Similarly, for the doctor and the hospital registration, and the security analysis said like we were not able to see any attacks possible. Next is the data storage and the recovery part. In the data storage and recovery, we have like implemented the idea of KN star algorithm, where among like the N shares, the K shares are required to retrieve the data. So what we have decided here is like we are giving one mandatory share to the patient. So even if the other shares are with the doctor and the hospital, without that one mandatory share, nobody can retrieve the data from the storage. So in this, by doing this, we are again protecting the data from being like misused or like used for some other purposes. So With this, I would like to conclude saying that like the protocol which we have introduced for the registration and the login and authentication is more secure and authenticated comparing to the other protocols. And also the secret sharing scheme that is used here that can be like implemented as the future work, that is the KN star, where one share is given to the patient and the remaining shares without the patient share cannot be retrieved. So that's, thank you. Hello.
Hello.
Yeah.
Yeah, Preeti.
Yes.
I just wanted to know whether this system which you have implemented, this is already existing, right?
Ma'am, like in the existing protocols, they haven't used like the ID based encryption or the timestamps for the communication.
So
Like
if
during
you
the
want to say like this, how many papers or existing systems you have studied?
sorry.
If you want to say this, in existing system, ID based, that what you have implemented, it is missing, right?
Like there are like separately ID based encryption schemes that is implemented, and there are separately login and authentication protocols that are there, but they are having their own drawbacks and defects.
So
But
that is
the
what I
main
would
aim
like
of
to
is like
ask you. What
yeah.
are the drawbacks of that systems? And did you overcome that drawbacks in your system?
There were like possibilities of few attacks like DOS attack or password guessing attack or impersonation was the major role. Like by incorporating both together, I was able to overcome all these, the DOS attack or the man in the middle attack, man in the middle attack, the eavesdropping, the impersonation attacks. Like either of the papers were like not like fulfilling either of these attacks.
So how many data sets you have tested, or how many test cases you have tested?
No, we haven't like used any data sets. We've just used the Skyther tool, the tool to verify the protocol which we have written.
Okay.
It's the automated tool that is used. So.
Okay. Thank you so much, Preeti.
Yeah, thank you.
Yeah.
Thank you so much for the presentation. And now we will move further to our next presenter, Jayavani M. And the paper title is An Automatic Early Detection of Melanoma Skin Cancer Using Fuzzy C Means. Dear presenter, you may please start your presentation.
My title is An Automatic Early Detection of Melanoma Skin Cancer Using Fuzzy C Means. These are the contents I used: introduction, objective, literature survey, methodology, and conclusion. The first one is introduction. The most dangerous form of skin cancer that can appear anywhere on the body is melanoma. Children and adults, various ages, can be affected by melanoma. Even more than women and men are affected by melanoma. So dermoscopy used to detect the malignant apparent tissue and rabbit for the skin cells. Malignant and non-cancerous melanoma cannot yet be distinguished with absolute certainty. So in our approach, Fuzzy C means and KNN and SVM hybrid method used to develop this to find out the whether it's melanoma skin cancer. Next, experiments are performed on thermoscopic skin cancer machine learning database from UC repository, and the following process are utilized. From the large phase 1, from the large amount of data, fuzzy rules are used to identify the color and texture. Phase 2, KNN and support vector machine are the classification techniques used to determine the depth of melanoma lesions and minimize the noise. Literature survey, the fuzzy C means technique is used to estimate the regulating parameters for level set evaluation as well as automatically establish the level set. The most intense are hierarchical KNN and HKNN compared in this paper to do the skin lessons are in melanoma similarity measured by the color and texture. The next one is skin lessons are evaluated based on the ABCD rules. Also applied SCVM technologies has been implemented in the layers. Based on that, identification and evaluation of texture performance have been used. As mentioned above, to remove noise data, improve accuracy and reduce time consideration, rule-based classification was used for the fuzzy partition, and also KNN and SVM classifier used for the clusters are compared. Methodology in our approach, fuzzy KNN and SVM are used to compare the performance and object is divided into two types. There are within a set and entirely within a set and not entirely within a set. These features are extracted using fuzzy clustering methods to take into account color feature space and color intensity and color changes and pigmented sign. KNN capturing the location near K and acting on the mainstream's end, and KNN classification broadened with advice. Its K values are selected randomly. In the SVM, multi-criteria problem solving that handle linear and nonlinear methods are utilized to compare membership function pairwise. These are the phases I used in this paper. Fuzzy set C means algorithm, and C classification, member function in the future extraction, KNN and SVM. The first one is fuzzy set. The fuzzy set is a crisp set. Each object represents a quality of members between 0 and 1, includes union and intersection extra. In the fuzzy set, sample data sets are used to applied as to CSV files with the decision table applied in union and intersect to make it crisp set. Fuzzy C means a data object in FCM is a member of all clusters to varying degrees of membership function between 0 and 1, opposed to each data item just being a member of one cluster. This unsupervised fuzzy classifier's goal is to group data into set number of categories. Each data point has fuzzy membership to each group depending on how similar it is cluster centroid. Fuzzy classification. The process of putting together the elements of fuzzy set is called fuzzy categorization. Essential features were listen whether benign and malignant have been identified and deleted with the extracting a pigmented lesson data sets. The new method authored to thermoscopy ABCD principle, asymptotic irregularity and border color and diameter. The more malignant the lesson, the higher the score. Features including color, shape, texture and measure from the data set aid in the diagnosis of benign or malignant melanoma or skin cancer. The future extraction. FCM is used to determine the value of measure of a member of given dataset using prototype and concept of falsifier M being utilized to identify the membership value of data. When restricting the triangular membership function for the fuzzy set, FCM extends the scalar membership and triangular secondary membership function. The verbal expression of the FCM algorithm is a series of ambiguous upper and lower numbers. Next one is the KNN. KNN uses the sequential forward selection algorithm. Use future selection is increase the classification accuracy. Each dataset was used to testing data and future selection process, while remaining datasets were utilized training datasets and were rated based how similar they were in the test datasets. Finally, test dataset have been employed to categorize the most often occurring nearby the neighborhood among the case samples. Next one is SVM. SVM is performed classifier that exhibits good accuracy in the diagnosis system classification of melanoma. Thermologists used to thermography instrument to make early diagnosis of melanoma. The machine learning approach superior performance in the skin cancer. Early detection has been empirically demonstrated, which is main justification for using support vector machine. Result overview. These are the results I got. The first one is a table which I taken from user repository. More than 366 data sets are used. Only these data sets showed. And this is table 2 is a result. Fuzzy and KNN, FKNN, FCVM, fuzzy SVM. In that, FSVM is the highest value which I got. And this is the chart which I got the result. The conclusion, An article discussed soft computing tool were considered, analyzed, and compared, showing test training and test data set. In this accuracy, these are the accuracy I got from fuzzy set 93.65, KNN 92.85, and FKNN 93.83, SVM 94.86, and FSVM 95.85. And the highest one is 95.85, which I referred. And these are the reference which I refer. More than 36 are references I referred. But this in this paper, 15 are I mentioned. Thank you, ma'am.
Yeah. Did you compare your results with other authors?
Yes, ma'am.
Which one? Which are the methods?
KNN, HKNN, especially more than 36 papers are referred. In that, only 3 papers are taken, which I refer for my title.
No, result. Whether you have compared their result with your results.
Yes, ma'am.
So, can you show the result overview slide? That result slide.
Result. No, previous researchers' result I did not mention in this.
Yes, that's why I'm asking you.
No, I did not mention, ma'am.
Okay. So then how did you think of this, that you should combine any 2 methods and go for the hybrid approach?
Because which I referred, which I studied for all the articles are below 95. I seen. So
how then you have the approach which you have combined, and if you have given a thought for this, that you can combine what you have combined, KNN and I think
SVM.
SVM.
Yes,
Is it right?
Yes,
So why not any other algorithms? Why only these 2? So how did you arrive to this conclusion that you should combine these 2? That is what my question is.
SVM approaches, it will show the superior performance. That's what I taken for the skin, and that also we can maximize the margin level for both.
Okay. Thank you so much.
Okay.
Yeah.
Okay, thank you so much for the presentation. And moving further, I would like to invite our next presenter, Priya Vij, to present her paper on the title Comparative Analysis of Image Augmentation and Data Duplication Techniques. So, dear presenter, you may please start your presentation.
Yes, ma'am. Ma'am, my screen is visible. Am I audible?
Yes, you are audible, and the screen is also visible.
Okay. Good morning, everyone. I, Priya Vij, PhD research scholar. Today, I present my paper on an enhanced deduplication model for image retrieval using deep learning. These are the agenda for today's presentation: abstract introduction, types of deduplication techniques, image augmentation, comparative analysis of deduplication approaches, deep learning assembles approaches, and comparative analysis of deep learning assembles for image augmentation, deduplication, conclusion, and references. Next is abstract. In today's scenario, data is growing very quickly. Each connected device generate and transfer a significant amount of data online. Devices can't process and store this massive data because of low processing and storage capabilities. For latency sensitive application, it is crucial to investigate alternate storage optimization approaches. In order to increase the efficiency, storage optimization techniques like dimensionality reduction and deduplication may be deployed close to the system edge. Next is introduction. Vast volume of data is generated by the internet, smartphone gadgets, and social networking site. As the majority of time, data is copied across several sites in order to achieve the availability, reliability, and disaster management. During its transfer across the network, this duplicate data places an additional burden on storing arrangement in terms of cost, space, and network bandwidth. The data deduplication is a technique for eliminating duplicate copies of repeating data. In this method, is store just one copy of data and give logical pointers to the duplication of data. The deduplication process requires comparison of data chunks. These chunks are further identified and stored during a process of analysis and compared to the other chunks within the existing data. Whenever the match occurs, the redundant chunk is replaced with a small reference that points to the other stored chunk. Next is text-based deduplication. In this text-based deduplication, it compares byte by byte at the folder and subfolder level. At the folder level, it is remove replicates at the folder level, and it is also known as solitary occurrence storage. But at the subfolder level, it also uses static and variable side blocks to eliminate duplicates, and it is also known as chunk level deduplication. Next is audio visual aid center deduplication. In audio visual aid center deduplication, here it refers to as picture or image, audio, and video deduplication. On images, we undergone through scaling, compression, rotation, cropping, etc. For image deduplication is applied. And on video, we break down the video into frames that represent different visual aspect. Video deduplication can be applied. And if each keyframe of a movie has number of visual elements that are used to construct hash function. In audio deduplication approaches, use similarity matching method. In video also we can use similarity based audio deduplication we can use. Next is image augmentation. Image augmentation is a technique by which we can artificially expand our data set. It is very helpful when the data set we have very low few data samples we have in our data set. In case of deep learning, this situation is bad as the model tends to overfit when we train it on limited number of data samples. Image augmentation generally use the parameters like zoom, shear, rotation, pre-processing function to increase the data samples. In KRS, we achieve image augmentation with help of function called as image data generator. Next is the comparative analysis of deduplication approaches. The comparative analysis we have done on the basis of text and image deduplication. The first constraint is storage. In storage, text-based data duplication stores the single replica of text file and remove the duplicate. And in image deduplication, a centroid is selected, and then centroid image gets stored, and transform metric is used for storing near exact image transformation. Next constraint is procedure followed. In that text-based data deduplication, chunk hashes are calculated using cryptographic hashing technique. And in image database deduplication, like methods like surf, fast, sift, extracting image features are used, and then hashing techniques are applied on these features. Then next constraint is our matching approach. In matching approach, in text-based deduplication, comparison is performed by, we have already discussed that comparison is by byte, and duplicates are detected. And image data deduplication compares exact extracted image features and then detects duplicate. Next constraint is index lookup. Text deduplication performs exact matching for index lookup to detect duplicate in storage, and image data deduplication, it performs image approximate matching for index lookup to find similarity in image. And the next is constraint is accuracy. Text-based data deduplication perform exact matching of the text, but in image data deduplication, it detects exact or near exact images. Next is deep learning assemble approaches. There are 4 types. First, we have SIFT. SIFT is scale invariant feature transformation. It first identify features in photographs and use them to compare and find similarity between images. Next is Simon's DenseNet. It is a type of neural network architecture known as Simon's neural network. It has 2 or more similar subnetwork. It employs 2 identically set up networks with identical parameters and weights. Parameter updating is mirrored across both subnetworks. Simon's architecture works well in such tasks because sharing weights among subnetworks reduce the number of training parameters, resulting in less data need and less tendency to overweight. Next is ensemble. A far superior model is produced by combining SIFT potent descriptors with adaptability of Simon's network, which generalize well when then trained with more data. An ensemble that has been put in use is a both say yes model, in which the SIFT algorithm and Simon network must both agree in order for 2 images to be declared comparable. Next is multi-scale CNN. The multi-scale CNN is based on Simon's network. In this, different CNN were utilized. This model effectively catches the subtle similarity between the images, while the other 2 CNN record the visual appearance of the picture. First CNN captures substantial invariance. Next is the comparative analysis of these 4 deep learning assemble for image deduplication. On comparative analysis, SIFT have 0.89% accuracy, Simon's have 0.94, and Ensemble had 0.90% accuracy, and multi-scale CNN has 0.95, in which multi-scale CNN have higher accuracy as compared to others. Here is the accuracy comparison, chart of accuracy comparison of deep learning assembles for image augmentation. Next is conclusion. Techniques for deduplication media have difficulties with quantifiability, high accuracy, and performance. More improvements are needed for feature extraction approaches like SIFT, SURF, BRISC, PCA SIFT to achieve quantifiability, accuracy, and performance. As a result, non-vulnerability, scalable, and cost-effective multimedia system deduplication solution is required. The Simon's network multi-scale feature made multi-scale CNNs computationally more costly than the SIFT Simon's assemble. Thank you.
Okay, hello.
Yes, ma'am.
Yeah. I just wanted to know that if improvements are needed for the feature extraction for the SIFT tool,
Ma'am.
then why you have chosen this tool?
Ma'am, SIFT tool, ma'am, I have chosen that multi-scale, I will work on multi-scale CNN for further.
But you have shown the accuracy results using SIFT tool also.
Yes,
Yeah,
ma'am. But we use the multi-scale CNN that because it secure higher accuracy from both, from all.
Okay, that means you are not going to use SIFT tool.
Yes, ma'am.
Okay, okay. Thank you. Thank you.
Thank you, ma'am.
Thank you so much for the presentation. And now we will move further to our next presenter. And I would like to invite Jayashakti SM to present her paper on the title Classification of Traffic Signal Images Using Deep Neural Networks. So, dear presenter, you can please present your paper now.
Am I audible? Hello.
Yes, you are audible.
Good afternoon, one and all present here in the meeting. I'm Dr. Jayashakti, working as a professor, associate professor on VIT Chennai campus. So the paper title is Classification of Traffic Signal Images Using Deep Learning Architectures. The main motive of this research work is to recognize the traffic signal. Okay, in the real time, when there is a traveling, okay, the vehicle may travel in a high speed. So we want to give a feedback to the driver about the signals he is encountering on his way. So periodically, the system will whenever during the travel, when this automatic system will just capture the image, a traffic signal image, and then it is going to give the feedback to the driver so that the driver can accordingly just take a action, course of action during his travel. And also the system can be used for the autonomous driving also. So that the main application is for giving a feedback to the drivers who is in sleepy or in a drowsy mode. So the objective is to recognize the traffic signals which will be encountered during the travel. We want to recognize these traffic signals with a high accuracy, because accuracy is the recall is more important for this real-time application. So we have used a deep learning architecture, two deep learning architecture for recognizing the traffic signal. The first one is the convolutional neural network, a simple convolutional neural network. And then the next one is ResNet 50 architecture. For ResNet 50 architecture, we have applied a transfer learning technique, and for the CNN, we have trained from the scratch. For training this traffic signals, we have used a data set, which is a publicly available benchmark data set, which is known as a German traffic sign recognition benchmark dataset, which is available in the Gaggle also. So basically, this dataset contains 130,000 images with I think it's 73 classes, and they have cleaned the dataset and they had dropped down and made it to 50,000 images, which is a clear picture, okay, without any occlusion or so, with some 43 classes. So with this data set, we have we made it a 20% of images for training. And among this 20% of the, for 80% of the images, again, the 20% of the images you used as a validation set, in order to validate the trained model. And the rest of the 20% of the images were used for testing. So we have designed a simple basic CNN model, where the simple basic CNN model is stacked with the 3 layers. All the 3 layers are convolutional layers. Followed by this convolutional layer, we have added a batch normalization, whereas this batch normalization is used for stabilizing the input images. And then next we have added a fully connected layer, and then a dense layer, and then 2 more fully connected layer with a 2% dropout. Why we added this 20% dropout as 2? To reduce the generalization error, which usually happen when we are training the CNN model. If you have more and more layers, there might be some errors. In order to reduce that, we have added a generalization error, a generalization dropout of 20%. And finally, we have added a softmax layer of 43 nodes or 43 neurons, whereas this layer is going to act as a classifier for classifying the 63 classes of the traffic signals. The next one is ResNet 50. So the ResNet 50 is a huge network, whereas it contains 42 convolutional layers. Along with that, max pooling and the average layer it contains. But the thing is, we cannot train this ResNet 50 from the scratch because we don't have that much infrastructure. So what we did is we used a transfer learning technique. So we have used the pre-trained weights of the ImageNet. Okay, we used this weights as the initial weights for our for the neural net for the ResNet architecture to train the traffic images. So this architecture, among these two architectures, the CNN architecture produced a high accuracy, And also all the precision vehicle FM score is also very high when compared to the ResNet architecture. And the most important thing is with the training time is very less when compared to ResNet. The CNN is smartly identify all the unknown images. So we have trained the CNN architecture only with the 60 epochs. With that itself, we could able to acquire a high accuracy of 97%. That is almost it's 98%. So the reason for not getting a good accuracy with ResNet is that the ResNet is since the ResNet is having some 48 layers, we don't know how many filters it is applying. There are so many filters. Okay, so because of this many filters, maybe the architecture is getting trained overfitted too much, and so the result is very less for us. And finally, if you see the accuracy graph, we can make out that it clearly says that during the training as well as in the testing, the curve is stable, so that we can say that the classifier, the CNN classifier is stable and it is performing better than the ResNet architecture. So due to time constraint, I could not able to present the graph for the ResNet architecture. The next one is the conclusion is that this automatic system, that is automatic traffic signal recognition system, is going to provide a feedback for the driver, and even this can be used on the autonomous driving system also. So this is going to give the proper feedback. So with this feedback, we can reduce the number of accidents. So it is going to helpful for both the drivers, both the people, mankind inside the vehicle as well as the outside the vehicle. And as a future work, we are planning to implement a more and more architecture to find out which is going to perform a good accuracy. And the main drawback here is, even though the CNN architecture is very simple, so that is we could able to acquire a good accuracy with a simple less number of layers. With the time is the training time is still high. We want to reduce that, and also we want to tune the parameters in order to reduce more and more errors. So the references are given over here. Thank you. Now, that's the presentation.
Yeah.
Thank you.
Did you compare your results with others?
No, ma'am, we didn't compare the result with others, but I have seen some papers. Okay, for them they got some accuracy like 96 or so, but the number of layers is too heavy actually for them. So still we need to work on this to reduce the layers. Still we have some 3 layers, convolutional layers, and I think we have used the number of filters as 156. So we want to still reduce that. And also we want to see the performance of the other architecture also. Currently we are working on efficient net. Maybe people are saying that is the latest network. So we are working on that.
Okay. Okay. Thank you so much.
Thank you, ma'am.
Okay, thank you so much for the presentation. And now we'll move further to our next presenter. And I would like to invite Raju Saginala to present his paper on the title Deep Learning Framework for Liver CT Image Segmentation and Risk Prediction. So dear presenter, you may please start your presentation.
Yeah, I am here to present the paper. Just give me a minute, I will share it. Yeah, is my screen visible too? Can I just confirm?
Yes, it is visible.
Okay, thank you. Yeah, good afternoon to everyone. My name is Raju Saginala from Gokaraju Rangaraju Institute of Engineering and Technology, Hyderabad, from the Department of Computer Science and Engineering. And here to that of experimental study connected on topic named as Deep Learning Framework for Liver CT Image Segmentation and Risk Prediction. The co-authors of this paper are Anirudh Verma, Hemant, and Srimant, Lakshman Chaudhary, and Saket. Also, we have continuous faculty support. Mr. Mallikarjun Rao, professor at GRIT. Yeah. Coming to the next part, going with the abstract. As you know, liver cancer is a life-threatening disease with an estimated deaths of 2 million per year worldwide. Due to availability of abundant computational power recently, the deep learning approaches have been explored in the medical field. Earlier, some attempts were made using neural network-based solutions for tumor identification in medical images. However, we require more computational effort to to convert the medical image format suitable for artificial neural network processing. In this regard, in our paper, we suggested a deep learning framework which can directly process CT images for detecting the tumor growth and also estimate the associated risk. For our experimentation, we have used LITS dataset for tumor detection and patient-specific details for risk prediction. Coming to the risk prediction, we have used various ML techniques that have been explored to identify most suitable one is used in treatment process of this lethal disease. And introduction to the liver. In recent years, developing health system has grown increasingly popular. Several recent studies have proposed machine learning based tele-diagnosis and telemonitoring system for detecting of tumors. In a human frame, the liver is maximum important frame. It has huge quantity of blood vessels and hooked up with many critical organs. Liver is the primary organ with most effective determined vertebrates, which plays many important organic functions. Like it involves in many metabolic activities, etc. And these you can see the data set images, liver images. These are the input data set. And coming to the data set description, we have taken the data from the documentation challenge. It consists of 200 CT scans, and each input image is of dimension 512 cross 512. And coming to the risk prediction thing, we took Indian liver patient record. It consists of 583 patient specific details with 10 input features such as age, gender, bilirubin, alkaline phosphatase, proteins, albumin, globin ratio, etc. And coming to the existing work, in existing work, image tests are the existing work. Like image tests give the better results comparatively to other types of diagnosis. Image tests like ultrasound, computed tomography, magnetic resonance imaging will aid to accurately locate the liver and to analyze the spread of tumor to any other parts of the body. CT scan. All these cross-sectional images are combined to form a detailed view. After that, we use deep learning approaches for image analysis. A CT scan can be used to measure the tumor size easily. And in the aspect of risk prediction, we have lab tests as a existing work. Lab tests are performed by clinical practitioners, which take the blood sample from the patient body and generate the medical report containing various statistical values. Most cases can easily treated based on the clinical trial reports. A particular blood protein called alpha fetoprotein is produced by malignancies and fetal tissue. This test might be used to forecast the risk of liver cancer. And coming to our proposed system, in this we create a model to segment the liver. The region growing approach is used to segment the interested region. This will help doctors make better automated liver diagnosis based on the images. Modeling a system in such a way that it predicts the possibility of liver tumor from alpha protein blood test results. And proposed system helps in detecting and thereby diagnosing the liver tumor even before they are formed. Here, adaptive machine learning methodologies are applied in our system. And coming to the literature survey, previous research papers we have gone through cancer statistics in the world. We gone through this to discuss about the severity of different emerging cancers across the world. How cancers are growing day by day. We can see in this paper. And next we have gone through efficient liver tumor detection using machine learning. This is a paper presented by Kalsom, Moin, and Maxud. it discussed about the unsupervised machine learning technique combined with the supervised mechanism that accurately performs liver tumor segmentation. And also we have used SMART framework for black fungus detection using VG19 deep learning approach. This paper is used to analyze how deep learning convolution neural networks are helpful in medical imaging. These are the research papers we have used. Before going to the implementation, you can see the hardware requirements and software requirements. These are the hardware requirements, and I prefer using Google Colab with GPU runtime instead of having local setup. And these are the you can see the implementation. This is the input liver image along with the ground truth. And as the first step, we select and view the data set, and we pre-process the data, like any missing data is available or any abnormalities in the data set. Then we go through the process of future selection and future extraction. Then we choose the model that is right for this data set, and we apply the model and train the model and get the results. This is the result generated after applying the model. And our model, our mainly deep learning model, CNN is the model we have used. In CNN, we can see the convolution layer as the building block of the CNN. It consists of a kernel with values equals to weights, and this is the input image pixel array. We usually it performs by multiplication by multiplying the two matrices, and it generates the results. This is used for future extraction purpose. And next, coming to the pooling layer, this is another layer we can see in the convolution layer CNN. In this, we will be averaging the input image pixel values, and so that we can enhance the picture quality, and we can extract the mu features from this layer. This is the architecture we built. This is the 50-layer architecture, includes the following layers. It is similar. It resembles to the ResNet 50 architecture. And in addition to this, we have we use unit learner as a transfer learning technique, in which we pass the parameterized ResNet 50 as a parameter for architecture parameter. And as a default, unit learner will use ResNet 34 as architecture, but we passed ResNet 50 to check the performance. And coming to the risk prediction implementation, this is the we take the database for liver risk prediction and then goes for the pre-processing the data set. And like in pre-processing, we can see the missing, handling the missing values and handling the categorical values and converting the categorical values to numerical values. These are the things we can see in the pre-processing step. And comes to the future extraction and splitting the data set into training and testing and applying all the different machine learning models. And after applying all these models, we saw that random forest performance of random forest is good. So we apply the we finalize the ranked random forest as number one, and we test their model and we validated, and we also built a UI, user-friendly interface to enter, so that the user can enter the details and can get the result as healthy or unhealthy as an output. You can see the random forest algorithm working. It works basically by dividing the entire data set into different subsets, and outputs of those individual decision trees are used together to form a final output. This final output is generated based on voting. This step is known as aggregation. In middle, we can see the random forest works on bagging principle. First, various subsets are generated from the dataset. The process is called bootstrapping. And you can see the results from liver city image segmentation task and results from the liver risk prediction task. This is the UI we developed, in which user will enter all the required details like age, total bilirubin values, the albumin globin ratios, protein values. All the input will be given. And after he clicking the predict tumor, he will get the output as healthy or unhealthy based on the input values. Limitations and future scope. As deep learning models are very need high computational power, like it includes size of the limits include size of liver CT picture, the time it takes to segment and pre-process the image, and high computational needs. User can in risk prediction, user cannot store the previously predicted values. Can only predict yes or no, healthy or unhealthy based on prediction only we can get. And future scope to this paper presentation is we can have a user login such that they can log their past prediction details and improve the model by, as we have used stable models. By instead of this, we can improve the models from the data entered by the user. Yeah, thank you. I am open for the question.
Yeah. How actually you will improve your model?
Yes,
What is your plan?
I didn't get you.
Hello. You mentioned that you will modify
Yeah,
your
ma'am.
model. You will modify your model. So
Like
what
we
are
have
your
used,
plans?
yeah. Like if you there is a page, we have developed a UA, user friendly UA, right? Then the patient comes and enter the different values. In this proposed paper, we don't have technique, we don't have method to store these values. In later, if we can store the values that the user after user have entered, the stored values can also be used for training the model, and like there will be recurrent training. Model goes recurrent training after the new data set on the new data set also.
Okay. Thank you so much.
Thank you, ma'am.
Okay, thank you so much for the great presentation. And now moving further, I would like to invite our next presenter, Aditya Anasune, to present his paper on the title Face Recognition Using Convolutional Neural Networks, CNN. So dear presenter, you may please present your paper now.
Yeah, good afternoon, everyone. As Aditya was not well, so I, Abhilasha, would be presenting the paper instead. So.
Anisha, if she is facing problem, can we have other presentation till then?
Yes, sure. So for now, we are moving forward to our next presenter. And I would like to invite Abhishek Suryavanshi to present his paper on the title Voice Controlled Home Automation System. So dear presenter, you may please present your paper now.
Good afternoon, everyone. We are from Vishwakarma Institute of Technology, Pune. Today we are going to present our paper that is the voice control home automation system. This paper gives the design and implementation of a new voice control home automation system that uses Google Assistant for giving user voice control as the input, and the smart home automation system using a voice control. It helps to control the electrical appliances by using voice command. So the system ESP8266 is a module for transmitting data for controlling the functioning for electrical loads, and the module receives the input signal from any device which have voice commanding by the Blink app. So compatibility such as smartphone. So the smart home automation system is beneficial for handicap or some aged people. So the system is solve the problem for switching on and off electrical appliances, because when user just have to give the command to control the appliances or electrical loads. So it is low cost and flexible home automation system. So it enables the user to use the home automation system based on the IoT. So home appliances like fan, light, we can control. And the fundamental purpose of the system is to control the electronic appliances based on situational demand of the user. So moving towards the objective. So by connecting the appliances with the internet, they can easily access from anywhere. So in the home automation system, the settings are visible through smartphone or other remote control devices like Blue Link app. So conventionally, we use switches and boards to control the home appliances, but with the help of this home automation system, we can access it from anywhere by using cell phone or web applications. So that is how functionality of applications get improved. So to become convenient for elder people who cannot walk, so they can easily control light with other electronics appliances. Therefore, it reduces the human efforts. So moving towards the methodology. So the system is designed by using two main components. First is Wi-Fi module, that is ESP8266, and the second is mechanical relay. So firstly, user gives the command to the using speech recognition system of smartphone and system software application via ESP8266 with connect with Blue Link. So the microcontroller acts as according to the command give the user to control the functionality of mechanical relay. So the Node MCU ESP8266 is programmed using Arduino IDE, which is a software. We have to connect the Google Assistant for a response our command. To add command, we have the applets in IFTT program manager. While we give the voice command as a off, the device are set from on to off working flow in the system. So the electrical switches work as two-way switches. So the voice command is sent by using built-in microphone and voice recognition system. So it implements in device such as Google Voice Assistant, and a microcontroller is implemented in system. The microcontroller receives the input signal from the user device and send the signal to respective relay for turning on and off electrical appliances to connect with the system such as bulb, fan, etc. So the system user interface devices in a smartphone and software which interface with Node MCU ESP8266 to execute command of user. So it is the previous slide we have discussed about the working system. So this is the flow diagram shows that the flow workflow. So let us move towards the hardware configuration. So for that we have used the Node MCU, relay module, jumper wires, and 5-volt battery. Firstly, the Node MCU. The Node MCU microcontroller unit, also called as the Node MCU, it is an open source hardware development board. It contains the chip called ESP8266, which is the Wi-Fi module used to connect the devices with the network. Node MCU is an inexpensive hardware that is suitable for the construction of the home automation system. Next is the relay module, which is the 4-channel relay module. The relay module is a series or array of the switches. It is used to turn on or turn off the electrical circuit. The relay works depending upon the input signals. The next was the jumper wires, which by which we have done the circuit connections. And next was the 5-volt battery. The Node MCU runs on the 5-volt and 3.3 volt. So we have used the 5-volt battery to supply the voltage to the Node MCU. So next was the software configuration. For that we have used the Arduino IDE. Arduino it is a software which is used to write the programs and connect with the microcontroller. It supports a simplified version of the C and C++ programming language. Second is the Blink configuration. For that we have used the Blink application, which was mainly designed for the Internet of the IoT. It can control the hardware Arduino, so Raspberry Pi, Node MCU, and several other boards over the internet using the iOS apps. And for that there was one Blink app which allows us to create the interfaces for our projects using the various widgets that we can provide to it. And there was one Blink server. It is responsible for all the communications between the smartphone and the hardware kit. We can use the Blink cloud to run the private Blink server, and it is an open source which could be easily handle thousands of devices at a time. Next is the Google Assistant. Google Assistant, it is a Google Voice Assistant software that is used to give the voice commands. The user can give the voice commands through the Google Assistant to access the smart devices and applications. It is a convenient method for the user to automate their devices. Next is the IFTTT website. IFTTT, it is a website that is used to create the simple conditional statement, which is called as the applets. To set up the IFTTT application, it must be logged in and the applets can be created. The commands given in the Google Assistant trigger the IFTTT applications. IFTTT connect the various applications and the devices. So next is a procedure for developing our system. For that, firstly, we have done the circuit connections. All the 4 relay are connected to the general input output pins in the node MCU. For that, creating the applets, we have used the IFTTT applications. We have first signed up with the Gmail ID, and to create the new applets, we click on the if this option and connect it with the Google Assistant using the Gmail ID. And after that, created a simple commands like turn on the light one, turn off the light one, and so on. And for creating the Arduino ID with the node MCU, the open Arduino software and enter the board manager URL of the node MCU ESP8266 in the preferences. So that is about the procedure. So let us move toward the result. The result of this paper provides the smart home automation system using the voice commands. By giving the voice command using Google Assistant, the lights and fans are turned off and turn on. The voice commands turn on light one is given by the user and the Google Assistant respond to that command. So let us move toward the conclusion. So the system developed has shown that home automation via the Internet of Things works successfully. By doing the connections by the circuit diagram, the system was able to control the light by mobile applications as well as the Google Assistant. The system is developed such that it can control the various home applications remotely, which can be helpful for not only elder people but for younger also. Home automation is undoubtedly a resource that can automate the home setting. People can use these home automation devices to control their electrical devices and create dominant actions via the mobile. In future, this product could have a high market opportunities. Any it will be incontestable for PC rather than mobile phones for connecting appliances of any giant places like the industries, hospitals, establishments, and etc. So that is the conclusion. So these are the references which we have referred. If do you have any questions, please ask. Thank you.
Yeah, no questions. Thank you. Thank you so much.
Thank you.
Thank you so much for the presentation. And I will request Abhilasha if she can present her paper now. Abhilasha, is it possible for you?
Actually, ma'am, I'm having trouble is presenting while presenting it. So I'm working on it. Can you give me 2 more minutes, please?
Okay, then try to
Yes, ma'am.
present
I'll
quickly.
be.
Yeah.
Yes,
Okay.
yes, ma'am. Sorry. Yeah, good afternoon, everyone. Sorry for the delay. So, I'm Abhilasha Bande, and the paper that we'll be presenting today is called Face Recognition Using CNN. We are the students of Vishwakarma Institute of Technology, Mechanical Branch, and yeah. So, continuing further. So, face recognition, as we know, is quite important in this tech-savvy world because it can be used in security services. Face recognition can be used in biometrics as such, biometrics, and like with Apple and Samsung, they incorporate. Face recognition, they have been incorporating face recognition as a primary a security primary source of security for the phones, security unlocks for the phones. And also what face recognition can help us is in the detection of criminals, because it can allow us to scan a huge database of people from like a general picture that is captured in an instant, and we can filter the faces to find the required face that we want to look for. Yeah, next slide. So the objectives that we had while approaching this particular topic was to make a CNN model from scratch. So after that, we collected and trained a data set of images for face recognition system. So this data set that we collected was it was created by ourselves. So the family members or the or other colleagues from we took their pictures, and we generated a data set comprising of about 15,000 images. And the number of people varied from the age group of the people varied between 60 to 50 years of age. And around we captured around we took the data we took the pictures of around 40 to 50 people. And another objective was to working on optimizing the results as much as possible. Yeah, next slide. So what is CNN? CNN is basically a convolutional neural network, and it is relevant in face recognition because it helps in feature extraction, because we can train these neural networks on neurons to capture these required features features or edges that are present in a person's face, and this helps in object detection. And because CNN has the ability to pick out and detect patterns, and it has the ability to make sense of them without without the requirement of pre-processing an image. So this is of great advantage, because like if we want to look for a particular person, and like let's say we have captured a image from a traffic signal or somewhere, so we can easily look for that person without having to actually pre-process the entire data set of that images. And next slide. This is the general architecture of CNN. Now it consists of various layers where a prior layer will perform feature extraction, and the next layer will perform the classification. And these progression layers will where feature extraction and learning part is completed by the initial layer, and the classification part is completed by the layer coming after that. Now these filters or neurons present in or the layers present in the convoluted neural network has the capability of detecting and differentiating between various patterns and features. And these layers will take an input image. It will detect the patterns and features that are present in an image, and then transport the input, transform, and then will give the input to the following layers. And it is called the convolutional neural network because it does this by convoluting the image through a specific kernel, and it will look for the specific features, and it will generate an output matrix. So the proposed CNN model. Next slide. So this is a proposed CNN model. It basically comprises. So we first take an input image where obviously which basically has a which basically is a real-time image, and it consists of different lighting features, and it could have major like people with mustaches, glasses on, anything. So we have to keep the image as generic as possible without so that it will enable us to help train the model better. The next layer would be the convolutional layer, and we have the convolutional layer is basically the brain of the CNN architecture. And here the input image is convolved with a kernel, a small matrix that is smaller than the input image, and it will result in an output matrix. And basically what convolutional layer will do is that it will just summarize the presence of an input image by applying the filter over the image, and it will basically extract the important features from the input image, and it will generate an activation result. Now further, the max pooling layer. Now, what the max pooling layer does is it basically reduces the size of the input data to enhance the computational speed of the network. And there are different kinds of pooling layers. There could be max pooling layer, sum pooling layer, or average pooling layer. We have employed the max pooling layer here after going through various papers, because it basically selects the maximum elements from a region, and it will only select the most prominent features. The next layer is so here we have repeated the convolutional layer and the max pooling layer. This was done after reviewing quite a lot of papers, and also because our data set that we generated had over 14,000 images. So so we decided to employ 2 convolutional layers and 2 max pooling layers. Um, we decided to go for 3, but that wasn't required because our data set wasn't that huge. So we decided to go with 2 convolutional layers only. And then we performed max pooling again to reduce the dimensions of the input data. The next layer was the flattened layer. Now, what the flattened layer does is basically it converts the multi-dimensional input data into a single dimensional array for inputting it to the next layer. So we employed one of this layer, and we got the output as 1 by 10816. And now the last layer was the fully connected layer. And what it basically does, it connects every neuron in its layer to the neurons in the preceding layer. And it provides all the outputs from the preceding layers to the neurons. And it is one of the most basic layers of the CNN model, CNN architecture. And here in there is a last layer called the fully connected plus softmax. Here there are around 40 neurons, where each neuron represents one class of the person. So basically we generated a model based on 40 people. So we employed 40 neurons over here to help predict the result. Next slide. Yes, this is the data set that we have generated. And as we can see, we have tried to make it as normal as possible. And we have tried to incorporate various angles. And as we can see, there is various lightings, and the lighting also differs, the camera quality also differs. So this has enabled us to train our model better. Yeah, next slide. Yeah, this is the outputs. So this is the comparative analysis that we did after, to improve the model accuracy. So as we can see in the first part, the number of neurons in the convolutional layer. So we by increasing the number of neurons, it increased the training time by around twice the training time that was required previously. But it gave us a maximum theoretical accuracy of about 99.69%. But when it was tested with actual images, it was only found to be 10%. So it's not always complete. It's not always necessary that increasing the number of neurons in the convolutional layer will give us optimal results. The next one, here we went for the softmax as the output layer function. This is popularly used. Softmax as an output layer function is popularly used. We compared it with ReLU, and when we found out that ReLU has just a maximum theoretical accuracy of 17% and a practical accuracy of 80%, as opposed to softmax, which had a theoretical accuracy of 99.8% and a practical accuracy of 95% compared to ReLU. So we decided to go with softmax. And later is the optimizer. So the optimizer basically enhances the model for more time efficient training. It changes the attributes present in the deep learning model, such as the learning rate and the weight, to reduce the losses as much as possible. Now, as we can see here, we have compared RMS prop and ADAMS. So the training time of the model differs, and it so while using Adam is also popularly used. So we got better results with Adam. So which is why we decided to go with Adam as our optimizer. Yeah, next slide. So the results that we achieved. So we could conveniently recognize the image that was provided after its training. And the change in the background or the lighting condition did not majorly affect the results. And and we prevented overfitting or the high variance of data. So in conclusion, next slide. So we got to learn a lot of new things about the CNN model as we built it from scratch. And we also created our own data set, which is a big achievement for us because we could uh, uh, we could actually see how the different kinds of backgrounds or lighting conditions could affect the CNN, could affect the model training, and how the accuracy of the model changes with such conditions. And we also got to see why CNN possesses such power and why it is relevant in today's world, with the increasing need of uh, with the increasing population and the increasing technology that gives it a better platform. So yeah, next slide. Yeah, these are the references that we referred. Next slide. Any questions? This is all from us. Any questions?
Yeah, hello, Abhilasha.
Yes, ma'am.
Yeah, I just wanted to ask the data set which you have uh, taken for testing purpose. That was created by you people, right?
Yes, ma'am.
So did you test your data?
Like test as in
What I mean to say is that whenever we are doing any projects, so all the tested data sets are available on Kaggle or UCI, right?
Right.
So yeah, so why we are taking that data sets?
Because they are pre-processed and like.
So whether you have pre-processed your data set.
Yes, ma'am. We tried to because the image size varied for certain images, so we tried to dimensionally make it all similar, all the
Yeah,
images.
that is fine. That you have done on your own.
Yeah.
Like we are saying that it should be valid data set. So did you validate your data set, or whether you approved your data set from such you can say library owners like Kaggle and UCI?
No, ma'am, we haven't done that. So, like we
Then
created and we
did you
tested.
compare your results with others?
Yes, ma'am.
Then how can you compare if there is no tested data set if you are using? Then how you can compare your results with others, because they might have used other data sets.
Right.
Yes. So what you have to do is that either you get your data, you can say authenticate by some you can say library owners, and then you can compare your results, or otherwise you can use the already available data sets, and then you can compare your results. Okay.
Okay, ma'am.
Yeah, fine. Thank you so much. Yeah.
Thank you.
Thank you for the presentation. And with that, we have completed all the presentations for today's session. And I sincerely thank all our authors for their excellent presentation and contribution in this session, and all the participants for being a part of this international conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during this version and the previous 6th version of the conference. And we will be happy to have you in the 8th version in 2024. All the presenters would be getting their digital certificates through email within 2 working days. And further, all the papers have already forwarded to Springer. So the publication will be live within 6 months. So kindly cooperate with the team of SMARTCOM 2023. I would also like to thank our session chair for chairing this session. And here is a small token of appreciation on behalf of the team of SMARTCOM and Global Knowledge Research Foundation. So thank you so much for your valuable presence, ma'am.
Thank you so much, Anisha.
Okay, so now as we have come to an end of the session, I would request you all to please switch on your cameras for a quick snapshot of this virtual conference. Okay, thank you so much, everyone. Stay safe and take care.